Hello everyone. In today's class, we are going to start new chapter, that is thermodynamics. What is the chapter name? Thermodynamics. This is a new chapter. From this you are getting LAQ for IP exam also. So first of all, let's see what is meant by thermodynamics. The definition of this thermodynamics. So basically, if you will see this word thermo and dynamics, है ना? Thermo and dynamics. So definitely there is something related with therm. Therm means what? Heat. So in this chapter we will learn the mechanism how the heat energy can be transferred into mechanical energy and vice versa. Okay. So I am writing the definition. See here. It is branch of science which deals with which deals with exchange of heat energy exchange of heat energy between between bodies and conversion of the heat energy and conversion of heat energy into mechanical energy into mechanical energy and vice versa. Okay, so what is the definition? See, thermodynamics is nothing but it is a branch of science in which we are going to learn how exchange of heat takes place between bodies and conversion of heat energy into mechanical energy. This heat energy we are going to convert into mechanical and vice versa. Means mechanical energy into heat also. This is what the definition of this thermodynamics. Okay. So note down this. Next one, what is the thermodynamic systems and how many types it is having? So let's see. So next one is thermodynamic systems. Thermodynamic system. Let's see what is this thermodynamic system. So this thermodynamic system means actually what it consists. Thermodynamic system means what? Actually what it consists and how that system is going to make. Okay, so how it will be. So first point, can I write like this? So first one, like this I am writing, it is a collection of, it is collection of an extremely large number of atoms extremely large number of atoms or molecules confined confined within a certain boundaries, within certain boundaries. For example, we know we have taken a piston and we have compressed that gas into one container. That is also one type of system, right? This is what thermodynamic system. So if I will consider a gas fixed in a one container particularly, or you can take like this system, one small thing I am taking, small example. Okay, so you can consider like this, one small piston I am considering over here, and okay, like this. Can you see? So in this is a gas, and you can see these are the atoms or molecules which are inside, and this is having boundaries also. Yes or not? You see, these are the all boundaries, right? This gas is enclosed, and these are the all boundaries, and this is called your thermodynamic system. What is this? A system. So now you understood what is thermodynamic system. It may be anything. It may be anything which has some boundaries and which contains large number of atoms or molecules. That is what your thermodynamic system. So I can write here example, that is gas contained in a container. Okay, this is what your thermodynamic system is. Next one, what is the surrounding. Okay, next one, what is the surrounding? Surrounding means obviously whatever outside the system, that is what surrounding is. But these words or this thermodynamic language we are going to use ahead, that's why better to clear all the concepts. That's why I'm giving you all these things. So these variables, thermodynamic variables, all these surroundings and system and all open system, closed system and all these things are very useful for understanding further concepts. That's why I am giving you now is all. So first to see what is the surroundings. So I'm writing like this. Anything outside the thermodynamic system. You can see anything. This outside is surrounding only. This is system. This is system and outside this is surrounding. Yes. So here I'm writing like this. Anything, anything outside outside the thermodynamic system to which to which energy or matter is exchanged. Energy or matter is exchanged. Okay. So you can see here, as this is a closed, so only energy can be transmitted. One example I can take, see, one example, if I have kept a pressure cooker here, just rough diagram I am making for your understanding. Suppose you are having pressure cooker like this, cut it, something like this. Okay, this is a pressure cooker. And now it is very hot. If you will see this side, this is surrounding. So if you will go near, you will observe that this part is also little bit hot. Don't touch it, okay? No need to touch. But just in this part, just you go little near to that, you will observe that this is also getting heated. It is what? It is a surrounding. But from this system, energy is getting transferred to this surrounding. So that's why surroundings is anything outside the thermal system in which or to which energy or matter is exchanged. Right? Clear? So let's move ahead. No need to write this, no need to draw this diagram particularly. You can write the content. You know this very easy. So next, what are the thermodynamic systems we can say? So thermodynamic systems and its types with example. Okay, thermodynamic system. So I'm giving you with types these thermodynamic systems. Wait, first listen. With one example, I am explaining. So how many thermodynamic systems we are having? So let's see. So first one, open system. What is first one? Open system. Open system. Next one is closed system. Closed system. And third one is isolated. Isolated system. Right? If this system you don't want, no need, because already these are the types of systems only. So no need to write this system. Unnecessary, the space will get wasted. If you have space, you can write. For me, I don't want this. Just thermal system, open system, closed system, and this one is isolated system, isn't it? Right. So let's see what actually the difference between these three: open, closed, and isolated. So in open system, what it exchanges, that is also matters. So in this open system, or when system is open, there is exchange of both matter as well as energy. Okay, so what it exchanges? Matter and energy. Energy and matter. Energy and matter. Here in this closed system, only energy. It exchanges only energy. In this isolated system, neither energy nor matter. Okay, neither energy nor matter. Neither energy nor matter. So open system exchanges energy and matter. So I am writing here one word, exchanges here in this exchange only energy, exchanges energy. And it exchange neither energy nor matter. Sir, can you tell us with one example each this thermodynamic system? Yes, let's see one example. So let's see the example for this open system. I'm taking a vessel. Okay, what I'm taking? A vessel, right? This is a vessel. So this vessel is open. Okay, this is open. and now these are the molecules or whatever gas or whatever it is. And if you are heating, what happens? This energy will get transferred, as well as this matter will also get transferred. These molecules will go up, they will get transferred. So here heat as well as matter both are getting exchanged. Next one I am taking, that is a closed system. You take, see here, this is a closed vessel. Okay, this is a closed vessel. Now there is a lid, there is no anything open. So these are the again gas molecules, we can say. Yes. Will these gas molecules come out? No. Yes or not? These gas molecules will not come out. But there is conduction between the surrounding and these walls. Okay, there is a conduction between these walls and these surroundings. So that's why they can exchange only heat energy. They can exchange only heat energy. And third one, that is isolated. So in this isolated system, what is the one more thing, that is it neither exchanges energy nor the matter. So this is a closed vessel, but extra is what? Extra is what for this? There is something, you see, like this. These are the walls, wooden walls, we can say. What are these? Wooden walls, which in which the system has packed. Right? Can you see? These are the wooden walls from all the sides. Yes, these are the wooden walls. So wooden walls, there is no conduction also. These are the wooden walls, so there is no conduction. Yes or not? There is no conduction. There is no transfer of energy nor the transfer of matter. And this is what the isolated system, understand? This is what the isolated system. This is closed system. This one is open system. Understand? In general life, in general life, do we have some examples? Yes. You take cup of tea for this. Yes. Next you take this as a pressure cooker, but whistle should not. Just it should not whistle. Okay. Just one container which is closed with a lid. But walls are conducting. Walls are conducting. So heat transfer is taking place, but not the matter. And this one you take thermos. Thermos, you know, hot water bottle you are having nowadays. Hot water bottle. You see, once you have filled hot water at morning time in that bottle, till evening it will be hot only. Yes. Why? Because there are the walls which will not allow to transfer the energy from inside water to outside surrounding. That's what isolated system. That's what isolated system. Closed system and isolated system. Closed system but conducting. Isolated system not conducting. There is no transfer of energy nor the matter. Understand? This is what we can say thermodynamic systems are. Open system, closed system, and isolated system. Yes, open system, closed system, and isolated system. Understood now? Yes, you can add your own points. If you want another example, you can take. Okay. So note down this. Okay, so let's move forward. Okay, finished. Let's move forward. Now, next one, thermodynamic variables. You know this already, we have learned. So what are the thermodynamic variables? You know, yes, you know, no thermodynamic variables. Thermodynamic variables. See, if you want to construct a wall, if you want to construct a wall, you require bricks, you require cement, yes, you require sand. So to construct the wall, you need these three things, basic things on which we can construct the wall. So similarly, if thermodynamics is there, it requires some variables, essential things to describe the thermodynamic processes and all these things. So that thermodynamic essentials are nothing but pressure, volume, and temperature. Yes, as well as internal energy and number of moles. So what are the thermodynamic variables? So can I write like this? Essentials, or you can say like this, without these all, we cannot describe the thermodynamic system. Yes or not? So thermodynamic thermodynamic system thermodynamic system can be described can be described by by specifying its pressure, by specifying its pressure, volume, temperature, internal energy, and number of moles. Number of moles. And these parameters are called these parameters are called thermodynamic variables. Are called thermodynamic variables. Yes. Right. Next one, that is equation of state. What is equation of state? Equation of state. So in one line, I want to tell you what is equation of state. Relation of thermodynamic parameters. That's it. Very simple. Equation which gives relation of thermodynamic parameters. Thermodynamic parameters. So already we have learned this. What is the equation? Can anybody? Yes, ideal gas equation. PV is equal to nRT. Yes, what is this? PV is equal to nRT, where n is what? Number of moles. Already we have learned this. Yes or not? This is what? Equation of state. Right? So equation of state means what? Equation of state means what? Equation which gives relation of thermodynamic parameters or variables, we can say. Yes. At the place of parameter, you can write variables also. Okay. What you will write? Variables. Thermodynamic variables. Or parameters, not an issue. Anything you can write. This is what your equation of state. Next one. What is mean by thermodynamic equilibrium? Next is what? What is mean by thermodynamic equilibrium? So see here. Thermodynamic equilibrium. Because in problem or somewhere they will say theoretical questions sometimes. What is thermodynamic equilibrium and all these things? So this thermodynamic equilibrium, when we can say that system is in thermodynamic equilibrium, if what? Let's see one flow chart. That is, it should be in mechanical equilibrium, it should be in thermal equilibrium, and it should be in chemical equilibrium. Thermodynamic equilibrium means what? The system should be in all these three equilibriums. What are that three equilibriums? Let's see. The system should be in these three equilibriums. What are those three equilibriums? Let's see here. If system you want to say that it is in thermodynamic equilibrium, I said what are the conditions we can say. The first one is mechanical equilibrium. Mechanical equilibrium. Mechanical equilibrium. It should be in mechanical equilibrium. Next one, it should be in thermal equilibrium. It should be in thermal equilibrium. Next one, it should be in chemical equilibrium. What is this thermal and all these things? Let's see in detail. So, what is this mechanical equilibrium? What is this thermal equilibrium? And what is this chemical equilibrium? So this mechanical equilibrium means there should not be unbalanced force. Okay, what is this mechanical equilibrium? No unbalanced force, no unbalanced force between system and surrounding, between system and surroundings. Okay, mechanics means what? Mechanics means the study of forces. Yes, and if any system is in mechanical equilibrium, it means what? There should not be unbalanced force. Always there should be balanced force. Thermal equilibrium means what? Right? What is the thermal equilibrium? System and surrounding must system and surrounding must be at same temperature. Same temperature at every point. At every point, or in all parts, we can say. In all parts. Clear? This is what thermal equilibrium. Chemical equilibrium means what? So, uniform chemical composition. Uniform chemical composition. Means there should not be any unbalanced chemical reaction, we can say. Uniform chemical composition throughout system and surrounding. Yes, throughout system and surrounding. Okay, this is what chemical equilibrium. Right? And if this all are in equilibrium, then only we can say that system is in thermodynamic equilibrium. Then only we can say that system is in thermodynamic equilibrium. Next one. Yes, note down this all. Next one. Next one. What is thermodynamic process? What is the thermodynamic process and how many processes we are having? Okay, so let's see thermodynamic process. Thermodynamic process. What is this thermodynamic process? So obviously, see, when any thermodynamic process is there, there is obviously the change in thermodynamic variables. That is what? Pressure, volume, and temperature. Yes. So the process which involves which involves change of change of thermodynamic variables. exchange of thermodynamic variables. Got it? So how many such type of thermodynamic processes are there? So let's see. Number one, isothermal, adiabatic, isobaric, isochoric, cyclic and non-cyclic, reversible and irreversible. So let's see how many thermodynamic processes are there. Let's take like this one chart. This you should understand, because in this when they are asking again what is meant by isothermal, what is meant by adiabatic, what is meant by cyclic and all. So that time you should understand. Okay. So how many systems are there? Let's see. Okay. So first one, that is isothermal. Which process that is? Isothermal. Isothermal. Next one, adiabatic. Adiabatic. Next one is isobaric. Isobaric. Next one, isochoric. Isochoric. Or you can also call it as isovolumic. Isovolumic. Another name for this system, for this process, isovolumic. Next, cyclic and non-cyclic. Cyclic and non-cyclic. Next one is reversible and irreversible. Reversible and irreversible. These are the six systems, right? Isothermal, adiabatic, isobaric, isochoric or isovolumic, cyclic and non-cyclic, reversible and irreversible. Reversible and irreversible. Got it? So what is this isothermal process? What is this isothermal? Isothermal. Isotherm means what? In this, temperature remains constant. What remains constant? Temperature remains constant. Such a type of processes where temperature remains constant, that type of processes are under this isotherm. Temperature remains constant. Isotherm. Isotherm. Therm means temperature or heat. So adiabatic. Adiabatic process. Adiabatic process means what? There is no transfer of heat. no transfer of heat. No transfer of heat. If suppose they are asking adiabatic wall, or they are saying giving adiabatic wall. Adiabatic wall means the wall which through which heat is not at all transferring. Next is isobar. Bar means what? Pressure. Bar is unit of pressure, है ना? मालूम है आपको? Bar is what? Pressure. Bar is pressure. So therefore you keep it in mind. Pressure remains constant. What remains constant? Pressure remains constant. Now here next one you see isochoric or isovolumic. Core means what? Volume. So in this system, what remains constant? Volume remains constant. Clear? Volume remains constant. Next, cyclic and non-cyclic. In cyclic process, initial and final states are same. Initial and final states are same, whereas in non-cyclic process, what? Tell me, initial and final states are different. In non-cyclic process, initial and final states are different. Clear? This is what your cyclic and non-cyclic process. Next one, reversible and irreversible process. What is this reversible and irreversible process? So in the reversible process, system and surrounding comes to the same state, we can say. In irreversible, it is not like this. So note down first this, note down. So in one line, I can say like this, I have less space here. Reversible means can be retraced back in opposite direction, and irreversible what you will get, tell me, cannot, है ना? Cannot be retraced back in opposite direction. That's what irreversible is. Reversible which can be reversed, है ना? Irreversible which cannot be reversed. So this is cannot. This is very, very important. Cannot. Here it is can be retraced back in opposite direction. Here it is cannot be retraced in opposite direction. That is what irreversible process is. Yes. So note down fast. Okay. Next. Next is indicator diagram. What is indicator diagram? Indicator diagram means what? Which indicates the diagram which indicates the relation between pressure, volume, and temperature or whatever it is. Yes. So in one line I am writing indicator diagram means the diagram which indicates, right? Because these diagrams are very important for calculating work done ahead. So just I am writing definition, right? So in simple language, the graphical representation, the graphical representation of the change in state of a gas by a thermodynamic process is called, what we can say, indicator diagram. So indicator diagram agar if suppose you want one example, I will draw one graph here which represents something like this: pressure and volume behavior. In Boyle's law also we have learned, yes or not? So this is what yours. If suppose I have taken pressure here and volume here, this is pressure and this is volume, and suppose now this is like this graph. So what it indicates? The change of state indicates, yes or not? So this is what you can say, one indicator diagram, right or wrong? How the pressure changes with respect to volume, and you can write this as the origin, and here it is temperature is constant, isn't it? Right, at constant temperature. So like this is what indicator diagram, which represents the change of state of a gas. Clear? So note down this all. This is very basic. Read one more time. Very slowly I have explained this theoretical part, because when we are going ahead, it is very useful. These all things, the basic things. So read, and if you have any doubt, please call me. Okay. So let's stop here. Bye for today. Enjoy the day.